Cool, let's get started. Hello everyone, my name is Trek. I am on the Ember.js core team. I'm a software developer at GROUPON in lovely Chicago, where it snowed, I believe, the night I left. It's quite a pleasant trip for me to come from snow to wearing a t-shirt. So I've just recently reached a milestone of entering my 30s, and pretty much my entire adult life I've been a software developer, primarily focusing on the web. So when I started doing software, why is my slide not progressing? Because Keynote unexpectedly quit. Cool story, Keynote. I didn't even upgrade to Mavericks. This is not even that. All right, cool. So when I started doing software development, IE4 was the thing. And so basically, like a lot of people in their early to mid 30s and going in the 40s, my software development career kind of tracks the development of the browser. And so I can sort of look at like geological ages of software development and my age and where my hairline was. So I think of software development a little bit like this. And I'm not specifically saying that a particular piece of technology has caused me to lose hair. But when I started, I had quite a bit more. And now a particular browser is on a evergreen upgrade cycle, so they'll be doing releases, every month or so. So yeah, I'm fucked. So it's been cool. I've been able to watch, sort of as my career has progressed, watch the browser go from a decent document viewer in the 90s to being a better document viewer in the early aughts. And then finally, sort of what it's become today, which is a passable application runtime and virtual machine. And I want to talk a little bit about sort of how that happened and technologies that we have today, and then briefly go on about Ember.js. So this is Amazon in 1994, very document focused. This is Amazon 16 months later. If you viewed source, this would be this like terrible mishmash of tables, but that's okay, right? Like developers are always pushing the boundaries of what the browser like officially allows us to do. And we push those limits to get the sort of experiences that we want, and we've been continuing going forward on that. So this was Amazon, and the reason they wanted to, craft a richer experience at this time frame was basically this. This is the NASDAQ. Was anyone working during this boom and bust cycle? Quite a few people. So NASDAQ was very tech heavy. This essentially was the lead up to huge economic growth based on the internet. You slap E or I in front of your company name, and suddenly people will toss millions of dollars at you for no reason. During that same time, we had the browser wars going on. And this was a war being fought between software vendors who made browsers, and the weapons of this war were mostly proprietary technologies. And they were putting proprietary technologies into the browser in the hopes that to craft the sort of experience that would get you the VC dollars, that would get you the customers, you would use their specific browser, so best viewed in Internet Explorer. And these features that were being competed with were things like filters, transitions, the ability to manipulate inner HTML, JavaScript event systems, iframes, AJAX requests. None of this sounds interesting because these are all things that we take for granted now. But there was a time where like browsers didn't have this, and vendors were tossing them in hopes of gaining larger market share, so they could essentially control the on-ramp to the super information highway, if you will. But then what happened? Well, that happened. In fact, you can overlay these two charts, and you can see tight correlation between the sort of ending of the browser wars and the bubble bursting. There's also that line. That was the finding of fact in 2001, June 2001, finding of fact against Microsoft, where the Department of Justice found that they, in fact, were using anti-competitive practices to make people use their browser. So the browser wars sort of dipped while all of that was happening, and towards the tail end of that scale, a new war was being fought, the Standards War. So these are books that came out, I don't know why I went in reverse chronological order, roughly early aughts to mid-aughts. And now the new war was being fought for how close could you match standards compliance. And we were getting away from building with tables and writing sort of better web applications using the technologies that they had. And browsers were now competing for who could have the best standards compliance, who could have all the cool CSS stuff that would allow people to craft richer experiences, which is great. But still, web apps kind of looked like this, very request response heavy. Who remembers the original MapQuest getting directions, right? Like you click the up arrow to move the map one tile north and wait 45 seconds. And if you needed to go several tiles north to get directions, well, hopefully you had a fast 56K modem. And then in 2005, this landed, and it wasn't the first Ajax-heavy application, but it was kind of the one that opened people's eyes to what you could do in the browser. And this started a third war, and that was a war for processing speed. So this started 2008, 2009. This is from John Resig's blog. So this is the first Chrome beta. Higher bars are better compared to the other browsers at the time. And of course, every browser began to compete for this. And there were some winners and some losers. Sometime in not long ago, but a year and a half ago, Chrome passed as being the most installed browser, Internet Explorer mostly losing ground. But before you think Internet Explorer is out of the game, obviously they are also competing for a browser that runs JavaScript and does layout much, much faster. So the green bar is the IE9 preview, and it just continues to go on. So we're getting better and better and better, which allows us to do cool things like this. This is a JavaScript library called crossfilter, and that's live filtering of 250,000 records of airline flights in the browser. So you can imagine you could craft a UI like this with typical request responses, but it would not be as reactive. It wouldn't allow people to drill down to the exact piece of data that they want to get quite as quickly. So cool, so we have a faster browser. But why? Well, like, what's the point of this competition? Especially because it's definitely not for rendering, right? Like to render a page like this, or even its modern equivalent, we had plenty of browser processing power 15 years ago to do something like that. In fact, it is to make applications like this. So this is Microsoft's Outlook, or applications like this, Wunderlist, or this, Flow, RDO. So towards the tail end of this application, or this period, the browser wars are slowly turning into a war for who's going to be the best application runtime. And it's a pretty decent application runtime that we've ended up with as a result of this war. You can structure and draw displays, you can manipulate them, you can make HTTP requests, you can store data locally, you can play video and audio natively, get geolocation, do pixel drawing, do vector drawing. Basically everything that you would think about as an application runtime that would run natively on a mobile device or on a desktop, you basically have that in the browser with the additional wrinkle of the things installed damn near everywhere, which is pretty cool. But for the most part, people are still roughly making applications like this. So if you think of everything that needs to go into making an application, from displaying data to figuring out what the screen's going to look like, to figure out which screen I should be rendering, to having away from keyboard behavior like receiving messages when the user's away, long-term persistence, people are usually doing this right now. So screen rendering, you have a Rails application, the screen gets rendered from a view, which screen you're rendered is determined by your router, you have asynchronous behavior going in the background, persistence is probably MySQL or a NoSQL database, and then the client really is just a dumb document display. Or maybe you've been doing this, where you split rendering kind of halfway down client and server. So you send a document over, and then you begin to manipulate it with something like jQuery, which is interesting, but it is not how client-server technology normally goes. So if you imagine you're writing something on a service-oriented architecture and you have a layer of APIs, your mobile device is probably speaking directly to that. Your desktop client is probably speaking directly to that. And then weirdly, your web client is probably talking to some intermediary layer that's rendering views, and that is then talking to your APIs. But I would argue the browser has come far enough that we really can just do this and restore sanity. So all client-server architectures, regardless of the platform where the client lives, is basically the same. So if you look at this chart, I'm essentially saying we should go from this to this. So this is starting to happen. It's been happening probably for the past couple of years. It's been fairly slow. So here's modern browser performance compared to IE7. So you can see, like, we're in a world where we can finally do this. And so this is finally happening, but it's still been pretty slow to get applications built in a real client-server architecture. The speed is relatively new, so people are still in the process of developing it. And frankly, the tool set is also very new. So on mobile, you have something like Cocoa Touch or the Android SDK. On desktop, you have stuff like Cocoa or .NET. On the web, well, what did we have? I would argue something like Ember, but Angular or Backbone is fine. But those are also new technologies. Each of those frameworks is about 2 to 3 years old. All of them hit 1.0 in the last year. So very, very new. So that's all I'm going to say about sort of historically why we got here. For the rest of the talk, I'm going to kind of demo Ember. My goal for the rest of this talk is not to get you fired up. If you've come to be excited, I hate to disappoint. I'm here to bore you. Because unless I've mistaken my audience, a technology like this can't be cool. It literally has to be so obvious and so easy and so boring that making the pitch to a manager or a CEO is obvious, right? Like why would we not, like, nobody ever got fired for building an Ember app is what I would like people to say in a couple years. So prepare to not be wowed. A Ember application is a stack of layers. There's a router on the outer end, and that determines what is the current rendering context and how do I fetch, and how does this encode to a URL. So that's the outer routing. The route is essentially what data should I fetch to be in this context? What template should I show? A controller says, how do I transfer intent, user interaction, into something more reasonable? So how do I say, turn a click in a particular part of the DOM to show me more information? And then also do I present the data I have out to the world? View template is basically how do I paint to the screen? And a model is, what is the structure of my data? And all of these are optional. So we have default behaviors. So if you don't need to customize the behavior in Ember, you are free to not use or implement any of these things. So here's the smallest possible Ember application. It's a line of JavaScript and a line of templates. And it is only using the view and the template layer. This will boot up and run in your browser just fine. Looks like this. And basically, you're just using a very, very thin stack of that. That's not probably terribly interesting to anyone. So here is a slightly more complicated Ember application. We have a router that's saying there are 2 URLs that I'm interested in. Those will map to 2 same-named templates, or you can specify a different path. And then the application template contains links to these various routes, and then a thing called an outlet. So who came from the Angular talk that was just next door? Oh, well, awesome. Wow, you guys are getting your money's worth. Like, you're literally getting the 2 main web development frameworks back to back. So if you remember, an outlet is a little bit like Transclude in Angular. So that denotes a portion of the template that will be later filled with content. So it looks a little bit like this when you play with it. 2 links at the top. You can transition between state to state. Of course, that sort of rendering isn't super interesting. You probably want to fetch data from a server. So let's extend our app. Here is, now I'm implementing a route. So remember, routes are dealing with what data should I be loading into my application, and also what template should I load. The template I should load happens to be defaulting to one that's named the same as the URL, so we don't need to implement that. And then what data should we load? So 2 things will probably stand out to you. 1, there's no success callback. And 2, we're returning a call to $Ajax. Who's ever returned a call to $Ajax before? Probably not. You probably were expecting something a little more like this. Set up a reference to this so that it's in functional scope. Show a loader, make an Ajax request on the success, do some rendering. We don't need to do that in Ember. The model hook of an Ember route is aware of something called promises. Promises are like a very tiny state machine that have 2 states, resolved and rejected. And when a promise resolves, you can pass on its data to continued execution in an application, and if it rejects, you can hand it off to an error state. And it turns out $Ajax is actually a promise. I promise it is. So we can just return that promise, and then when a response comes back, flow of execution will continue, and then we can render. So we can turn our about handlebars into that, and the data automatically gets passed down to the template. And then we can do the same for our favorites route. So just make an Ajax request. The response will automatically get passed into the template returns, and change the template to that. So that's data loading, pretty simplistic. So that's also not terribly interesting. It's kind of a toy application. It may be hard to understand what's going on. I'm going to take you through one of my favorite experiments. That is to take a real-world application and reverse architect it, or reverse engineer it to figure out how would I build it in Ember. So we're going to take a look at Rdio. Has anyone used Rdio before? Music player? Wow, so few people. Feel free to crack it open and start playing with it while we go around. So I'm going to take you through a series of interactions and pseudocode out how I would implement that in Ember. And again, the goal here is to show you how repetitive and boring writing this kind of application has become. So Rdio starts out at a loading screen, eventually transitions to this. So you load up the app, you get a loader, and then it'll transition to this and move the loader to another location. In Ember, it would look something like this. We create a new instance of an Ember application. I've given it an empty router, and then we'll give it a single route for the entire application. And the model for this route happens to be the user's context itself. So the application template is just an outlet, meaning we'll dump data in there at some point. And then there's also a loading template, which by default we will put into the outlet while data is being fetched, remove from the outlet when data has been fetched, and then insert whatever template should go there. So you get loading state behavior sort of automatically. So that loading gets put into the outlet, and then it gets a response comes back with some data about me, and then that gets dumped into the template. So we've transitioned to this. Let's look at some of the stuff in isolation. So links on the side will go to different parts of the application. So we have a helper, which I guess would be called a directive in Angular, to link to additional states that turns that element into a thing that can be clicked on, and will tell the router to move the application into a different state. Looping, so if you remember the response that came back, where was it? Did I skip past it? There it is. Included an array for playlists. And so we just loop over those playlists, and for each playlist we're going to link to one particular playlist, so now we can go view that playlist, and then just display its name. And then you can see where the data is coming from and going into the template. So the top bar, pretty similar, should be getting really boring for you. Class of top bar, some links to additional routes. Here's where data is coming from and getting put into the template. And then finally, another outlet. So outlets can be nested inside each other, so you get this cascade of data loading and templates rendering. And we will later on fill that outlet with some content. So here's the interaction again. We've gotten to that point, and then data comes back, and now we have this. And this just happens to be the heavy rotation screen, which is coming up next. This is how I would implement this in Ember. I would, this is our application so far. Here's what I'm going to add to it. So down at the bottom, or at the top, I've added a heavy rotation route in the router, and then implemented a route object. It's making an AJAX request. So loading screen automatically gets put into there. Response comes back. And finally, this renders. We can take a look at some of the areas of this in isolation again. So a bit of a template, and you can see where the data is coming from and pointing to some additional links. So I've made the entire div that is the album a link to more information about the album. So how would we navigate to an album? So the interaction looks like this. You click on the top left album, get a loading screen, and then you're looking at the album. So how would we do this? We would add a new album route map in the router, and then an album route. It fetches some data. So loading screen, we automatically put that in for you. Some data is returned, and then boom, re-render the page. Okay, who's bored stiff so far? Nobody? All right, well, I'm going to keep going, because remember, my goal is to bore you. So what about deeply nested routes? So it happens that artist is a deeply nested route. So if you clicked on the artist's name, Dale Earnhardt Jr., never listened to this artist, actually don't know what the music is like. That will put a loaded page up and then take you to this page, which actually has sort of two bits to it. There's the artist stuff at the top, and then it will immediately show album. But you can click songs, which will then display a loader, and then display the songs. So in Ember, it would look like this. Instead of just making a route, we would add a resource, which is how we denote a model that has data nested inside of it. It gets a URL, and then it has a function callback that become the routes inside of it. Two route objects, well, three. One for the artist, So that'll say, pull me out the artist, one for the album, and then another one for the artist, songs, so albums and songs. Some things to note, the path, this route albums has a path of /. That means when you enter the artist route, it'll automatically transition into the albums route, which is the behavior that we saw in RDO. So here we are, loading screen automatically applied for us. This renders, so we've rendered the top part, which is the artist, and then immediately transition to render the album data. If we click songs, the outlet, sub-outlet is automatically filled with a loading screen, and then we can see the songs. And that can continue for the biography, related artists, etc. Okay, so what about playback? This is a thing, so now we've mostly just been rendering, but how do we enact and take actions in our application? I kind of skipped over this in the beginning. If you're wondering how the lower playback bar got rendered, just hand waved around it. So if you click on a particular artist, it will begin playing. So this is the application outlet as it stands right now, but as you can see here, we also need the little play bar at the bottom. So I'll add a second outlet. You can have as many outlets per template as you want, and they can be nested as deeply as you like. So this one is named playbar. And now because we have custom behavior in terms of rendering the template, we have something we'd like to do in addition to the default behavior. We'll implement a render template method, which we'll call super. So the default behavior will occur. And then we're also going to render the playbar into the application template into the outlet called playbar. And then we get this. All right. So template would look a little bit like this. For each of the tracks, go through listing out the track number and the name. And then to make them clickable so that you can play, we add this action tag, which would be a directive in Angular, that says play this. And this is the current thing that we're iterating through. And when you click, these bubble up through the application structure. So the first target for any action is the current controller. And if you don't implement an action called play there, it will go to the current route. And if you don't implement an action called play there, it'll just bubble up through all the routes that are nested all the way to the application route. And since playing is something that's going to happen application-wide, I'm in fact going to put it on the application route. So it looks like this. You click the song. This is the argument that gets passed through. It happens to be the song. Now we're going to access a controller. So this will be our first controller that we've done. We haven't needed one yet, so we haven't had to implement one, but now we do. It's pretty bare bones. Looks a little repetitive, but this allows us to isolate playback behavior to just the controller and to access it from anywhere in the application that can be able to play by clicking play. And it turns out the application is filled with places where you can play. So anywhere in the application you can click the play button. It'll hit the current controller where you might want to implement custom behavior for that route or that controller, then the current route, and then bubbles all the way up to the application route and goes and plays. And I think that's all I had. That shockingly took me a long time to put together because of the number of screenshots, but it was pretty quick to go through. So I will pause for questions and answers. Yes, in the back.
So when the data store is finished and sort of release ready, is that going to be merged into the main project for Ember, or is that going to be a separate thing like this now?
So the question was, there's a separate project called Ember Data, which involves higher order data modeling. So you don't just have to be like, oh, fetch, $Ajax, fetch some data, put it in. The question was, will that be merged into Ember Core when it's ready? I think that is the plan. What it will look like when it gets merged in is pretty unknown. We had a large core team meeting where we can't agree yet as a core team, like when we feel the crossover point to put that in it will be a good time. So if you want to do more data modeling, there are basically 3 large data modeling libraries for Ember. Ember Data, which involves some people from the core team, Ember Model, which involves different people from the core team, and Ember Persistence Foundation, which is some sort of community project. So I don't know. In the back?
So with the client-side rendering, you usually have to move over something that can parse templates, fetch data, as opposed to where it renders to the server side, maybe Classic Rails app that doesn't have to do it. So have you done any comparisons between, say, initial page load time?
Mm-hmm.
Because there's a trade-off.
Yes. Yeah, so the question was, or is there more to the question? Okay. The question was, have we done any benchmarks on moving more and more rendering into the browser? No, I mean, it's hard to do benchmarks on that because it's fairly anecdotal. But since we have time, we can actually do demos.
Wouldn't it be dependent on the client machine?
Yeah, it depends on the client machine. So did that, oh, you can't see that. Let me, dang, and now it's gonna be cached, so it's not gonna be fair.
It's less about actual time to render and more about how long does it take to get the user something they want to like.
Yes. So can you guys see that?
Why is it black?
I don't know. No, it's not supposed to be black. All right, well, this will be, I think if you mirror displays, it's not very happy. Let me just, can you see that? All right, good. All right, well, this will be interesting. I'm going to be controlling this. Here, let me reload this page. So this is a fairly standard actually, let me load this in my Chrome so that I can have the developer tools open. Oh, where is my mouse? All right. So pretty standard content site. And feels pretty zippy, right? So this is actually an Ember application. I would not normally recommend people write Ember applications that are content sites. But if you look at this site on an iPad compared to a statically rendered application of similar, so like TechCrunch or something, you'll find that rendering speeds are initial rendering speeds are about the same. So on an iPad, this will render in about 2 seconds, whether you're sending data from a server and that's already rendered into a view or you're doing the view rendering on an iPad itself. The place where it then makes up speed is subsequent loads. Let's see if I can, oh man, control this, clear that out. So when you load another article, whoops, that may have tossed a whole new screen. Sorry, it's really hard to see and control. Anyway, they're, oh, hey, Zac Efron. The subsequent loads are actually super fast because they've already delivered the template payload to the browser, and they're just sending out a tiny bit of JSON data to do rendering. So rendering speeds seem about the same. One thing that is still new and hard to deal with, people know how to do caching with pages and page fragments, right? So when you visit twitter.com, that is heavily prepared for you, and you get instantaneous result, essentially. Caching of JSON, especially through something like Rails, is a little harder. Rails is heavily optimized for caching pages, not so much for JSON. So anyway, the long answer is anecdotally, they seem about to be the same speed initially, and then I think faster responses going on. Actually, while I have this open, all Ember applications have, even in production, you can inspect them through an inspector. So you can see all the templates that are going into this and inspect the routes. And this will tell you exactly what the route name is, the template name. If you need to implement a controller or route object, it'll be in there for you. And there's even cooler things than that. So you can take a look at, where's my mouse? Take a look at that. It'll crack it open. You can see what the data loaded are, the properties. So we have really good debug tools.
That's a browser plugin?
That's a browser plugin, yep, for Chrome. There's one coming, someone's working on one for Firefox as well. So, yes?
So since we had both of them back-to-back, I have to ask,
Uh-huh.
why would I choose this over Angular?
They're pretty similar products, honestly. And if you were to build, or even Backbone. So the question was, sorry, now that we have had them back to back, why would you pick Ember over Angular, or even, I guess, Backbone? They're all very, very similar. Total application size for any substantial application is going to be almost identical. There's no escaping complexity, right? Like an application is going to take a certain amount of code. The real question is how much application code you have to write. Backbone is probably going to be the most application code. Angular and Ember will be pretty similar in smaller application code. The thing Ember gives you over Angular is application structure. Angular application structure is kind of left up to the developers. They've even specifically said, like, they moved routing out into its own package. and they're going to handle it as a as a plugin essentially, whereas Ember enforces an application structure. So if you like making decisions about how to architect applications, or you have something that's very, very strange and you need to architect your own way, probably Angular. If you're like me and like the tyranny of choice will keep you from ever developing anything, and you basically just want someone to have solved these problems for you and tell you like, here's what you name an object, here's where you put data fetching code, here's where you put template loading code, and then you can get to the work of like building your product. So I consider myself more of a product builder than an engineer. Then I would pick Ember. Yes.
If I have an Ember application and I want to make a link
Mhm.
to the same host name
Mhm.
as the Ember application is running on, is that possible?
You mean just like a regular href? Yeah, yeah, yep. Just toss an anchor tag in.
I'm asking it because I know in Angular it's not. So
Yeah, yeah. It's just so we have the link to is how you create links within an Ember application. If you just put an anchor and URLs.
slash whatever,
Mhm.
and it won't try to take it
Yeah.
over.
Yep.
That's nice.
Are there any accessibility or scannability issues with the fact that it's not well-formed markup templates?
Mhm. So the question was, are there usability or accessibility concerns given that it's not well formed? What do you mean by not well formed?
Well, you've got the curly brace.
Yes.
In the middle of
Yeah, so the curly braces in the middle element. I should have mentioned those get compiled by the framework into HTML, and so it is just HTML in the end. There's Yehuda Katz has a really funny video. Someone was like, it wasn't specifically about Ember. It was about single page applications. Like, well, accessibility as a screen reader gonna go use that, and he was like, turn on accessibility options on your Mac. Go to an application. Does not matter if it's rendered on the server or rendered on the client. Like the technology has progressed to the point that the browsers are very capable of doing that. In the back?
A lot of people would be concerned about how these pages get crawled,
Mhm.
over SEO and all of that stuff. Can you talk about that?
Mhm. So the question, paraphrase, was essentially SEO. How the fuck do you do it with a single page application? So there are a couple of options. Google will not natively crawl a full client side application. There are a couple of ways to get around the concern. One, if you're writing a full application, sometimes it doesn't need to be crawled, right? So I work in the financial engineering team at GROUPON. We do all of our UIs in Ember. Obviously, we don't need search engine optimization, so it's not a concern for us. The second is actually let's see if I can pull up this site. So Discourse is an open source application. Is it down? There it is. It's an Ember application, and you get neat features like scrolling to particular places. They note everything a person does, can develop reputation for people and posts. If you had JavaScript off, which is going to be really hard to show because I can't see the screen properly, they will just actually serve up a static site. So the same thing that's rendering their application, they'll just render a static view with links, basically. This will probably come out hopefully next year sometime, kind of a quick boot process. So you'll be able to pre-render applications using likely Node, anywhere that has a good JavaScript runtime, pre-render them. So you'll be able to send them down to request. So you could, boot an application in a particular route with data put in there and all the data connections made, and then the JavaScript would kick in later and sort of enrich in it. And that would also work for SEO. And then there are third-party applications that will like crawl with Phantom and render the page and then serve that up for you to Google. So there are strategies. It's a sort of still pioneering area of software development. So what I imagine will actually happen is Google will just get able to crawl these, and then this will stop being a problem. Any more questions?
For promises, what do you use? Like Q?
We use a library called RSVP.
Your own Groupon?
No, it's not Groupon specific. So Ember is not a Groupon project, I should clarify. It's just an open source project that I happen to be on the core team of. No, we use RSVP. We picked it over Q. So if there's promises, which is like a large evolving spec. Q covers a huge amount of it. RSVP is like a third the size, and really just covers the resolving and the rejecting stuff that we need.
Have you looked at Meteor?
Yes. The question was, have I looked at Meteor? Yeah, I've built Meteor apps before. It was all right. I unfortunately don't get to choose my server technology very often, and I feel like that's the world a lot of people are in. So for people unfamiliar, Meteor is a technology that is both server and client, sort of one mushed together stack, and can work really. I mean, you write applications very, very quickly in it. Unfortunately, like I said, I don't get to pick the server APIs I talk to. Many people don't. So that's that. You know, Meteor is a great thing if you can control the full stack. Yes.
Yeah, so I have a question about the concept of just all of this client-side web design in general.
Mhm.
What your opinion is of it? It seems like the more and more JavaScript that I use, the more and more problems the people in the public seem to have with the websites that I make or that I'm involved in.
Mhm.
Mainly because they use an old version of IE,
Yep.
or they use Windows XP, or I can't control what's on their computer and what they're doing. Why suddenly the big push towards this form of designing websites that's causing these problems that
Cool.
I didn't have or already fixed?
So the question was, given that you are likely to run into errors in the browser, that you wouldn't have, or I guess you'd still run into errors on the server, but you'd have better notification around it. Why this big push to move encoded? Right. Yes. Yeah. You can control it. So the cross filter example of being able to take a large data set and live manipulate it would be very, very hard to do document driven. So I think it's a move towards people wanting a more desktop-like experience in applications, and that's just the price you pay is you have to work in JavaScript.
See, I find it, I think that it's interesting that you said you don't really encourage people to use like Ember to make a website that's like high concept.
Yep.
You mainly don't use Ember to make tech launch or something like that, something that's usually facing the
Yep.
public sector. Do you feel like Ember's place is more in design or developing applications that are going to be used inside of business internally?
So the question was, do you think Ember is, better used inside a business or internally? I think anything where you want a client-like experience is a good fit. That does tend to be internal apps very frequently, but there are obviously external-facing apps. Anything where you want an application like it. So Square's dashboard, for example. Does anyone use Square, the credit card reader? I run a small business on it. Their dashboard is an Ember application that uses cross-filter. We can jump in and very rapidly find a particular payment, find a person, look at all their payments, look at charts and graphs, and manipulate them over time to figure out, like, oh, we're doing a lot of day passes on Thursdays. Let's figure out why. So we can drill down to that data very, very, very quickly. So yeah, I guess, do you think that counts as internal as opposed to? Yeah, so basically anything where you would like think to yourself, I'd write an iPad app or an Android app because I want a rich experience. It's now possible. There are better tools for saying, well, I can also make that available in the browser. And then unfortunately you'll have to reproduce that code for Android and reproduce that code for iOS and reproduce that code for Microsoft. But if you're doing service-oriented architecture, they should all be talking to the same API. More questions? In the back? Super testable. Let me pull up some tests from an application that I have. I probably shouldn't be doing this. let me find it. There, you can't see this yet. Good. Let me find a test that does not disclose trade secrets. Yeah, it's. I mean, it's fine. So I'll show you what some of our integration tests. Find one that's kind of more interesting than not. All right. I probably won't get in trouble for this. Can you guys see that? Should I bump that up a bit? Yeah, all right. Sorry, I'm gonna bigger. Is it getting bigger? All right. So these are integration tests, and these run headless. They don't actually script a full browser. They're exercising the way that like integration tests that are not JavaScript based work in a Rails application. They don't actually like spin up a browser. they're just exercising the parts of the code that they know work. So we can, log in, visit pages, click on things, stub out HTTP responses. So that's integration tests. And then unit tests, you can take a look at the project's unit tests. Everything's very heavily unit tested. And we're not specific on any, I'm going to pull this over really quick. We're not specific on any particular testing framework. We happen to use QUnit as the project core, but it's not like integrated very tightly. So let's see if I can find something. Trying to find well. I often use Karma, which used to be called that unfortunate name Testacular, which was the test runner that was extracted from Angular. I quite like that, so I use it in plugins for Ember that I write. So, yeah, you may be asking the testing question because Angular had a very, very central testing story, and we were also as testable. We just didn't make it part of the marketing essentially. So, other questions? Yes. I love the number of questions, by the way. This is awesome.
In the examples you provided, your routes were mostly 5 lines long and only about 10 or 20% of the characters actually varied.
Yes.
Do you have a recommendation on how to repeat yourself less?
Yeah, I use Coffeescript, I guess. So yeah, a lot of the stuff is highly patterned. In that case, we have a prototypal object system. You could write so if all your routes are following a very similar pattern, make a super route and have its model behavior be repeatable in some way, and then just have all your routes inherit from that. You can in fact just reopen the main route that gets used by default and provide behavior, in which case your router would be like the route map, and then you wouldn't have to implement any of the route objects because they would all just behave in a standard way, and then you could just not have to deal with that code, which would be very, very nice. So, yep. Other questions? I left so much time for questions. Things you'd like to see? I'm trying to think of cool Ember apps that are out there. A lot of these are in development still, so it's hard to show them. Anything? All right, cool. Oh.
When you were listing wars, you mentioned the client-side template engine war. How do you think that that's done? Did you guys pick one, or is it plugable, or you have your own?
So the question was, I didn't mention the client-side template engine war. So Ember will run anything that compiles down to the handlebars runtime, which includes handlebars. There's a couple others. There's man, it's so hard to do this. Emblem. So if you don't like HTML like markup, there's Emblem, which is inspired, obviously by Haml. We'll also run. There's a couple others. What is the biggest downside to Ember? So as a core contributor, like all I can see is the flaws. Part of this is the nature of the ecosystem right now. It's not what I would like to see is the ability to say when someone hits the main application, I would like you to load the code for these routes, which would include the views, the models, and the templates, and nothing else. And then as they navigate, to do additional code loading. So like an AMD style thing. Unfortunately, there's no standard module system. There's no standard loader system for any of the web. So to do something like that, we would unfortunately have to make decisions that would then essentially be a giant FU to people that wanted to use different module systems, different loader systems. So there's a project called Ember App Kit that will at very least allow you to use AMD style loading, but it's not progressive loading. That's something I would greatly like to see. So the use of promises means there is data sort of happening asynchronously, and it can be very hard to debug when something goes bad in what is essentially a callback, because you'll get totally out of context failures and not know where the original failure occurred. So that's kind of a pain. But Chrome is putting better promise behavior right into the browser. So soon you'll be able to see that. We're actually adding a promise tab to the Ember inspector. So you'll be able to see outstanding promises, their current state, if they erred or anything. So those are two big things. I could go on and on about things I don't like about Ember, don't worry. In the back?
Yeah. So like many, I just came from the Angular talk, and I appreciate
Mhm.
one did. You make all these little mini usable apps, just really compartmentalized.
Yep.
Do you have any thoughts on that for Ember? Because it seems like it's kind of a full, like you're going to have routes and you're going to have a whole application and you're going to build cardio
Yep.
and not just a couple of loops.
So if you don't want to use the routing behavior, you can actually have multiple applications on the page at once. But then you need to control when rendering occurs as you transition. For something like that, I would tell people go use Angular. Yeah, Ember's sweet spot really is stop treating the browser like a document renderer. It's a blank slate. It can draw boxes. It can make web requests. It's a moderately passable application runtime that will hopefully improve and allows you to deploy everywhere pretty quickly. Probably one more question.
Do you see Ember or Angular moving into the full stack as well as the other, extended to server scripting as well?
So the question was, do I see Ember Angular moving full stack so you can use it in a JavaScript environment on the server? Maybe. So we Ember, although we talk about Ember as one big thing, it's actually like 18 smaller libraries. One of them is the object system, and people do use that in Node applications occasionally. But no, this is pretty specific to the browser. Yes.
Have you browser compatibility testing?
Mhm.
Like how far back do you guys try?
So the question was browser compatibility. We use Sauce. Has anyone used Sauce Labs before? I can't say enough awesome things about Sauce Labs. They're very good. They run your tests in a multiple browser suite. So we basically support IE 6, 7, and onward, and modern. Yeah, we support IE 6. So the downside to that is IE 6 rendering speed is abysmal, right? IE 7 rendering speed also abysmal. IE 8 rendering speed is all right. IE 9 and 10 are now good. So although you can target IE 6, I would say don't. And I think we're in good company saying don't. Google, Facebook, plenty of places are just dropping support for 6 and 7 as it becomes a smaller market of part of their market share. Yeah. So because I get to work internally, we basically say any current version, latest or previous revision of a browser, including Internet Explorer. So it's like I'm living in the future. It's pretty awesome. It's really, really nice. I think, all right, we could probably do one more question, then you should go eat or something. One more question? No? All right, well, thank you very much for coming. I'll be around if you have more questions later. Thank you. And obviously at the drink up tonight, please, drinks are not on me, so come drink as much as you like.